All right, so we're going to take at the last look at the last way that we're going to solve quadratic functions. So this is the quadratic formula, and you have taken a look at this before. So this is just kind of a quick review of the quadratic formula. So quadratic formula means something that you would have to memorize in order to use. Now, there are other ways to solve, and you don't have to use a quadratic formula, but it's a good way to check answers, or just to get answers. So the first thing we need to do is make sure that we are in standard form. So everything is on one side of the equation. Everything's set equal to 0. And then we're going to identify our A, our B, and our C value and plug them into the equation, and then we are going to simplify. So looking at the first example here, so our A value is 1, B is 7, and C is 10. So go ahead and plug them into the equation. So we have a negative B, so negative 7, plus or minus square root of B squared, so that's 49, minus 4 times A times C, all over 2 times A. Alright, so we've plugged in A, B, and C. We're going to simplify this now. So inside the root, so we have 49 minus all this multiplied together would be 40, so that ends up with a 9 inside. So we have 7 plus or minus the square root of 9, which we know is 3. And then 2 times 1. Okay, so make sure you're following along with your calculator to make sure you're getting the same answers as I am. So we have negative 7 plus 3, which is negative 4, divided by 2 is negative 2. So we have an x value of, I want to get rid of that, negative 2. So negative 7 minus 3 is negative 10, divided by 2 would give us a negative 5. Alright, in B. So this one, we have to move everything before we start. So we have to move that 7 to the left. So subtract 7 from both sides. And that would give us this. So we have 1, a 3, and a negative 7. Okay? So we could plug those into the quadratic formula and simplify it and get it down. So I'm going to skip over that one, but I just wanted to make sure that we knew that we had to get in standard form. So again, we're going to move. Now you can move everything to the left or the right. It does not matter. So we need to move that 13 over. So subtract 13. Now we can go ahead and plug in. So we have x equals, I'll do it up here, negative b plus or minus square root of b squared, which is 16, minus, let's see, I'm not going to write it out. So 4 times a, which is negative 1, so that's negative 4, times negative 13 would be positive 52. So we're subtracting a 52. Okay. Make sure you get that same calculation. All over 2 times a. So 2 times a would be a negative 2, because a is negative 1. Go ahead and simplify the square root first. So 16 minus 52, that would give us a 36, negative 36, So square root of negative 36 we know is 6i over negative 2. Everything can be divided by negative 2. So we have a positive 2 there. We have a plus minus 3i. And then that just turns into a 1. So when we divide plus minus by negative, it doesn't do anything to it. It still stays positive or negative because it's both. So we would have 2 plus 3i and 2 minus 3i as our two answers. So it is possible to get complex numbers in this. In example 3, Abigail tosses a coin off of a bridge into a stream below. The distance in feet the coin is above the water is modeled by this function, f of t, where t represents time in seconds. So how much time will it take for the coin to hit the water? So we need to calculate when height is 0. So we're putting a 0 in for f of t. And we're trying to find the x-intercepts. Plus 112. All right, so now we can go ahead and plug it into the quadratic formula. So we have x equals negative b, so negative 96, plus or minus. If we do 96 squared, so 96 squared minus 4 times negative 16 times 112 all over 2 times a, which is negative 32. Okay, so we need to be really careful about order because this gets messed up a lot. So 96 squared, and we're going to write that as a value, and then we can do negative 4 times negative 16 times 112, and then we're going to combine that with the 96 squared, and then take the square root. So after we do that, and again, make sure you are calculating along just to make sure you're getting the right answers. So the square root of the number inside that we get should be 128. All right. So negative 96 plus 128, we should get, it'd be 32. So 32 over negative 32. Sorry, I need to write this as two separate ones. So negative 96 plus 128 is 32. 32 divided by negative 32 would be negative 1. And then we get negative 96 minus negative 128 divided by negative 32 should be 7. Okay. So what is the maximum height the coin reaches? So what we do is we have to find that we have our two x-intercepts, and we need to find the axis of symmetry to find our maximum, our vertex. So if we take negative 1 and a 7 and we go halfway between them, so let's see average, we get an x value of 3. So our axis of symmetry is 3. So x is 3. I'm just going to write this real quick. Axis of symmetry. So if we know where our axis of symmetry is, we know the vertex lies on the axis of symmetry, we can go ahead and we can plug this x value into our original equation and solve for y. So we can find the height when time is 3. So Obviously, these are all t values. I wrote x because that's what we're accustomed to, but that's what the, we can change that later. So we plug it in. Plug it into the equation. So f of 3 equals, once we plug it in and simplify, we end up with 256, and we're in feet. So 256 feet is the maximum value that the coin reaches. Okay? All right, let's take a look at, skip over that. Same deal for the checkpoint. So discriminant. So b squared minus 4ac, that's the thing inside the square root. So if we can remember, it's just the value inside the root. It helps us a lot. So the discriminant tells you how many solutions that the quadratic is going to have. So if we look here at this little chart, if it's a positive value, it's above 0, that means I'm going to have 2 x-intercepts. And it makes sense because I can take a square root of a positive number and I get a positive and a negative version. So that's 2 answers. If the number inside is 0, equal to 0, if I take the square root of 0, it's 0. So I'm not adding or subtracting anything to the other numbers in the quadratic formula. So that means I'm going to have 1 value. And then if it's a negative number, means so less than 0, that means it's going to be a complex number, because we know if we take the square root of a negative number, we get a complex answer, which we've learned throughout the last few weeks that if we graph a quadratic that doesn't cross the x-axis, it doesn't have a solution. So that's this situation where we have complex answers. So example 4, so find the type n number of solutions for each equation. So we need to first put it all into standard form, just like we do when we're using the full quadratic formula. So add over 7. And all we have to do is think about what b squared minus 4ac would be. So b squared, so negative 6 squared is going to be a positive 36, minus 4 times a, which is 1, times c, which is 7. So 4 times 1 times 7 should be 28. 36 minus 28 is 8. So this is a positive number, so that means we're in this first situation here. So above 0, that means we have 2 real solutions. 2 real solutions. Okay, so same thing here. Plug in our A, B, and C after we move everything over. So add 9. Now we get b squared is 36 minus 4 times a times c. So this situation we get 36 minus 4 times 9 is 36. So we know that should be 0, which if it's equal to 0, we're going to have 1 real solution. Part C, I have to move the 11 over. So add 11. Now we can plug in. So b squared 36 minus 4 times 1 times 11. So we get 36 minus 44. So we get a -8. And that's going to mean that we have no real solutions. So we can say no real solutions. We can say two complex solutions. Okay, so two complex solutions. It's the same thing as 0 real solutions. So you got to know that they mean the same thing. All right. So let's talk about the last example here, and we'll wrap up the video. So find a possible pair of integer values for a and c, so that the equation ax squared minus 4x plus c equals 0 has one real solution. Then write the equation. Okay. So first thing we need to know is we're dealing with a discriminant, because all we want to prove is one real solution. So discriminant, we know we're using this. We're using b squared minus 4ac, and we are equaling it to 0 because we want one solution. Okay? Now we do know a b value. We have -4 here. So we're going to plug this into the discriminant. So -4 goes here. We get -4 squared is 16 minus 4ac equals 0. Okay? So we can just see what AC has to be right now, or we can start solving. So we can move the 16 over. So subtract 16 from both sides. Divide by -4. So AC equals 4. Okay, some of us could have seen that before. That's fine. So AC is 4. So all we have to do is think of a combination of numbers that would multiply to be 4, combination of integers. So we could say A is 2 and C is 2. Okay, another combination could be, and you don't have to write all the combinations, you just need one combination. So 2 and 2 would be your answer. I'm just going to write a couple more here though for other people. So we have 4 and 1. We could do 4 and 1 the other way. Okay. We could do two negative numbers, so all of these could be negative. So -2 times -2 would still be a +4. And same with the 4 and the 1. So go ahead and try the checkpoint. We'll pause the video here. Just wanted you to try this. So we have this given value up here, so we know the b is 3. So we're going to plug that into our discriminant. So b squared is 9 minus 4ac, and we're looking for a possible two real solutions. So two real solutions means that this has to be greater than 0, positive number after we simplify this, if we knew what our a and c were. Okay, so move the 9 over. Okay. Actually, we can just, so, yeah, we'll move the 9. We'll do it this way. Some of us, again, can think about what these could be to make this situation true, but I'm gonna work it all out for you guys. So divide by -4, so AC has to be greater than 9/4. Okay, so 9/4 we know is 2.5, so any combination above 2.5, so we'll say bigger than 3, A and C, so we could say A is 1 and B is 3. Okay, so actually, what we gotta do here we gotta go back. Messed up a little bit. So when we rearrange these, so we have a negative here. We're dividing by a negative. We have to remember to flip that sign. So we get 9/4. Okay. So the other way you can handle this too, because some people forget about it, you can, let me show you this over here. So all you gotta do is we could move the entire values to the other side of the equation. So if I added 4ac to the both sides of the equation and I added 9 to both sides, we would end up with 9 is greater than 4ac. So that would give you 9/4 is bigger than AC. So now we know it has to be smaller than 2.5. So we could say that A is 2 and B is 1. We could say many different things. We could have a combination of 1 positive and 1 negative. Still would give us this situation. Okay. All right, so that wraps up the video. So go ahead and try the homework that I give you and let me know if there's any questions, but this is review. So hopefully it goes well for you.